All right, morning everybody. My name's Chris Webb. I work at Microsoft on the Power BI Customer Advisory team, which means I help large customers be successful with Power BI and then take their feedback back to the rest of the product group. So all of those times you wanted to shout and scream at the Power BI product, that's my job. I channel your rage, send it back to the product group, and make sure that the people who build the product go in the direction they should go into. And what we're going to talk about today is performance tuning, Power Query, and data flows. Now, the interesting thing about this topic is that it is a gigantic topic. It's a gigantic topic I've talked about several times in the past, or have attempted to tackle several times in the past in presentation. I think to do it justice, you probably need a 3 or 4 day training course. So the challenge is, how do we get it down into 50 minutes? The way we do it is we focus on certain things and leave certain things out of scope. So the first thing to say is that when I'm talking about performance tuning, Power Query, and data flows, I am going to be talking about Power Query in Power BI and not Power Query anywhere else in the world, not Power Platform data flows, not Power Query in Azure Data Factory or anything like that. I'm only going to be talking about import mode when we talk about data sets, because the Power Query engine does get used for direct query mode somehow. I'm not going to be talking about analysis services performance tuning for refresh, which is very, very closely related, but I'll try and kind of put that out. And what I am going to be talking about is the basic knowledge you need to be able to do Power Query performance tuning, which means that there won't actually be that many examples of me taking a Power Query query and tuning it, because in order to get to that stage, you need the basic knowledge, which is what we're going to talk about today. So what are we going to talk about? First of all, the first thing you really need to understand, the thing that is completely counterintuitive and the thing that throws everybody, is what actually happens when a Power Query query executes. Because in most cases, it does the exact opposite and behaves in a completely different way to the way you would expect. And unless you understand how Power Query works, you will not be able to do any tuning. Next, we will talk about how you actually measure performance, because again, it's not straightforward. It's not easy to know how long your Power Query query actually runs. And unless you know how long it runs, you're not going to be able to do any tuning. Then we will talk about query folding and streaming semantics. This is probably one of the areas that you're most familiar with, because it's one of those topics that comes up a lot inside conference presentations. We will talk a little bit about data flows and the enhanced compute engine if you're using premium. We will then talk about buffering and memory, which is one of those little-known topics which is massively, massively important. And then towards the end, there'll be some specific examples of things you can do. And then we'll finally talk about stuff that happens in Power BI Desktop, which slows things down, but which doesn't necessarily happen in the Power BI service. OK, so thinking about our scope, like I said, I want to talk about Power Query performance tuning, and none of the other stuff that goes on when you refresh your data set. If you were thinking about refreshing a data set, there are several different things that could need to be tuned to make your data set refresh go faster. Because when you've got a data set, the first thing that happens is when you refresh your data set, that's something that happens in the analysis services engine. The analysis services engine then reaches out to data sources via the Power Query engine. It gets data from data sources. Those data sources might themselves need tuning. The data gets brought back through the Power Query engine. Transformations might take place there. And then the data gets brought back into the analysis services engine, and various in-memory structures are built to build your data set. So today, we're only going to focus on the Power Query bit of that. Something very similar happens if you're working with data flows, except that there is no analysis services engine in data flows. What happens when your data flow refreshes is the Power Query engine gets data from your data sources, it does transformations, and then just dumps the output in ADLS Gen 2 storage. If you're using data flows in premium, though, there is an extra thing that can happen called the enhanced compute engine, which can be good for performance. And what happens there is when your data flow refreshes, after the initial pool of data has dumped data in ADLS Gen 2 storage, the enhanced compute engine means that that data gets loaded into a database behind the scenes. and then any further transformations happen in Power Query on the data that's held in that database. And then the data gets dumped out to ADLS Gen 2 storage. So that's setting the scene. Remember, we're only going to be talking about the Power Query engine, and, well, the Enhanced Compute Engine counts as Power Query. Now, like I said, the first thing you absolutely have to get your head around when doing any kind of Power Query performance tuning is what happens when a Power Query query executes. Because, as I said, it's completely counterintuitive. Now, before we go on to this, I'm going to show you the real-life counterpoint to this diagram. So I'm going to go to the Power Query editor in Power BI Desktop. So this is going to be a super, super simple query. I have SQL Server running on my PC. It has the AdventureWorks database on it. It's old school. I'm old school. I don't care. And what am I doing? I have got a Power Query query called dimDate, which connects to the AdventureWorks SQL Server database, connects to the dimDate table. And all it does is just return all of the data in the dimDate table. Now, if we then go to query dependencies, and we have a look at this, forget about that, forget about that. Look here, I've got the AdventureWorks database, it's going to dimDate, and then I have two queries that reference that dimDate query, called Mondays and Tuesdays. Oh, come back. Didn't like that. So here's Mondays. Mondays is very, very simple. All it does is filter the table brought back by dimDate, so I only have the day name Mondays. So I'm filtering the English day name of week column on Mondays. And then I have another query here called Tuesdays, which does exactly the same thing. And it just filters English day name of week by Tuesdays. So we're connecting to SQL Server. There is a dimDate query that gets everything from dimDate, and two reference queries called Mondays and Tuesdays, which just filter Mondays and Tuesdays. How does this work? What happens when this query executes? Well, I know what you're thinking, and it's wrong. Because the obvious thing you would think is, well, all right, when this query runs, we get the data from SQL Server. It goes through to that dimDate query. We grab all the data from dimDate. It goes through there. And then somehow that data gets kind of stored in the dimDate query. And then a filter is applied to it to get the Mondays and Tuesdays. So that data stored in dimDate gets kind of brought in once, and then it kind of gets split in two. Kind of like data, water flowing from a source right down to a destination. So, that data in dimDate, we've got it once, we'll split it in two, we'll kind of bifurcate it, we'll get the Mondays, we'll get the Tuesdays. This is not how things work, people. However much you want it to, it's not how things work. What actually happens? Now, if we're loading Mondays and Tuesdays into our data set, we've got two tables in our data set. Analysis Services says, well, OK, here's my Mondays table, here's my Tuesdays table. Let's refresh both of them. It'll refresh them in parallel, generally speaking. But when Mondays refreshes, what happens is the data comes from SQL Server. It goes to dimDate, and then it flows through to Mondays. And then when the Tuesdays table executes, we go to SQL Server, we go to dimDate, and we go to Tuesdays. So logically speaking, the dimDate query is executed twice. Now, it's more complicated than this. So we're not grabbing all of the data twice, as we'll see. But logically speaking, dimDate is executed twice. Now, apologies for my art, but the way you have to think about it is around those lines. There is a blue box around what happens when Monday is executed. There is a red box around what happens when Tuesday is executed. So these are two separate things, two separate pipelines of stuff. And in fact, when Mondays is executed, what you think of is actually not just the steps in Mondays, but all of the steps in Mondays and all of the steps in all of the queries behind that Mondays has a dependency on. And when Tuesdays is refreshed, what happens is all of the steps in Tuesdays plus all of the queries that Tuesdays has a dependency on. Now, like I said, it's more complicated, but we're going to build up to what happens. So we know roughly what happens, but the next important thing to understand is that actually we've been thinking about it, again, wrongly in a different way, because when the query executes, it doesn't start at the beginning and go to the end. It starts at the end and works its way back to the beginning. So when Analysis Services says, I want the output of Tuesdays, instead of starting at the beginning and working through to the end, the Power Query engine says, well, here's what Analysis Services is asking for Tuesdays. How do we work back through all of the steps back to the beginning to get that data? This is the most complicated thing to get your head around. When it does this, it kind of compiles all of the steps in the query you're executing and all of the previous steps into one big chunk of work. And it doesn't execute the stuff it doesn't need to. It may try and streamline how all of these transformations work. And it may also try and push as much of that work back to the data source. This is what we talk about when we talk about streaming semantics. And query folding is really just an extension of what actually happens inside the Power Query query. Now, it's hard to explain this. So what I'm going to do instead is show you an example. It's maybe a little bit scary in terms of the code, but this is going to be, I think, the best way of explaining what's happening here. All right, so let's open up the advanced editor, and I will show you what I've got here. Walking through this code. First of all, I have a step called source. Doesn't connect to a data source. It just has an array in it, a list. And this list has got 5 numbers in, 1, 2, 3, 4, and 5. So nothing special. It's kind of just like an array of numbers. Now, the next thing I've got here is a function definition called waitAsec. This function takes a number, and then it waits a second and returns exactly the same number. So it doesn't do anything except every time you call it, it is guaranteed to wait a second. Okay? Then call function here uses the list.transform function, and it will iterate over everything in that source list, the numbers 1, 2, 3, 4, and 5, and it will call my waitAsec function. So, how long do you think this is going to take? Well, it's not a trick question. It's going to take about 5 seconds, because it is going to take a list of 5 numbers, it's going to call a function 5 times, and it's going to take 5 seconds overall. And then at the moment, the query outputs call function. There is another step called first value, but this step is not being evaluated, because when this query runs, I'm saying, give me the value of call function. Call function is this. Call function relies on the source and the waitAsec functions, which are defined back here. And the Power Query editor, or Power Query, works its way from the back. Works its way from the back to the front. OK. Now, here we are in the query editor. Let's click Refresh Preview and count along with me. Mississippi 1, Mississippi 2, Mississippi 3, Mississippi 4. Well, I was a bit too slow. Anyway, it takes a noticeable amount of time. It takes, about 5 seconds. Let's see what happens, though, when instead of getting that call function step, we ask for the result of first value. What does first value do? First value says, well, here is the output of call function, which is looping over that array of 5 values and should result in 5 function calls. But first value says, only get me the first item from the resulting array. Now, the question is, when I ask for the output of first value, How long does the query take to run? Does it still take 5 seconds? Let's see. Click Done. And let's refresh the preview. Actually, I don't know what it is, but it's faster. I promise you, it's faster. Why is this? Well, it is because first value only asks for the first item in the list. The Power Query engine says, well, OK, I want the first item of call function. Now, this iterates over 5 items in a list. But I don't want to do that, because I only want the first one. So it'll only call the function once. And it won't actually iterate 5 times. It will iterate once. It will call the function once. And it will just say, well, give me the first item from source, call the function once, and then go through the end. So it's clever. It knows what it's doing overall, and it's kind of pushed that back through. So this is what we call streaming semantics. It's trying to avoid the steps that don't need to be executed, and it's trying to avoid even doing work within those steps that aren't necessary. So even though it's tempting to think of these steps as individual pieces of work, they're not. They are kind of logical steps, but they are not physical pieces of work that will always be done. And this is incredibly important for performance tuning. OK. So now we know what happens when a Power Query runs. The next question is, how long does it run? Because if we're doing tuning, we need to understand how long a query takes to run, because if we make a change, we hope to make the query run faster and not slower. Now, this is where I'm going to put my hand up. I work for Microsoft. I am a little bit embarrassed that it is not easier for you to find out how long a Power Query query runs for. Because you would hope there would be a little dialog box that pops up somewhere that tells you this. This does not happen. It turns out, actually, that it's also a little bit more complicated than that, but let's see. So how do you work out how long a query takes to run? The way I do it is using SQL Server Profiler. What am I using SQL Server Profiler for in a Power Query presentation? Well, I will show you. If we go here and cancel this, yeah, let's do that. So I've got my Power BI file. I've only loaded Mondays and Tuesdays into the data set. Now, when I refresh, like I said, the analysis services engine goes away, grabs the data from those Power Query queries, and does some stuff. And even though the tooling for Power Query leaves something to be desired, the tooling for analysis services is pretty mature. And we can use SQL Server Profiler to connect to the analysis services engine to see what happens when analysis services refreshes. And it turns out that in amongst all of the interesting information we can see about the services engine in Profiler, we actually get some really interesting information about how long the Power Query queries take to run. Now, how do I connect Profiler up to Power BI Desktop? There's a number of different ways. The easiest one is, first of all, after you've installed SQL Server Profiler, it's a free install part of SQL Server Management Studio, so you don't need to buy anything. It's all free. There is a Power BI external tool that will actually launch SQL Server Profiler already connected to your Power BI Desktop instance. So I can just click SQL Server Profiler. It will open Profiler here. Ever since I installed Profiler 18.11, for some reason, it launches with a Profiler trace already running, which is not what I want. And instead, what I'm going to do is I'm going to stop this trace. It's still connected. And then I'm going to edit it. I am going to use the template blank, because I don't want any of the standard events. And with no event selected, I am going to select command begin and end, which is kind of useful to see when the analysis services activity begins and ends. So let's select those two. And most importantly, I'm going to select these progress report begin and end events. And it's the progress report end event we are particularly interested in. progress report begin and end are kind of internal events raised by the analysis services engine when it does some stuff during refresh. And one of those things that will raise an event is Power Query related stuff. So let's go and get progress report begin and end. Let's click run. And let's just refresh the Mondays table, for example. So let's refresh the data. It's going away, getting data from SQL Server, loading the data into analysis services. It's done nice and quickly. Let's go back to Profiler. And let's stop this. And we need to do a bit of rearranging. So I'm going to move event subclass over. I'm going to go and find the text data and the duration columns. Move those over here. And in here, we've got a whole bunch of really interesting information about what the analysis services engine does during a refresh. And what's the first thing the analysis services engine has done? It's gone to Power Query to get the data. And there are two particular events that we are interested in. Now, the first one that we are going to be interested in is this one, this progress report event, which has the event subclass 25 execute SQL. You can see there's a bit of M code here. That's not actually the M code. It's some extra M code that gets executed on top of your queries. It doesn't do anything. But we've got a duration here of 1302. That's 1.3 seconds. It's milliseconds. What this event represents is the amount of time it takes for the Power Query engine to return the first row of data from the query. So from this, we can see that the Power Query engine returned the first row of data after 1.3 seconds. The next interesting event is another progress report end event, which will be reasonably soon after in this case, which is the read data end event. And this has a duration of 6 milliseconds. This is the amount of time it took to return all the data after that first row got returned. So you kind of put these two together, you know the overall duration of your Power Query query, as measured from inside the analysis services engine, which is as good a way of measuring things as any. Now, these two numbers could vary. Depending on what's happening inside the Power Query query, you might get the first row of data streamed almost immediately. So that first number could be absolutely nothing. But then the second number, the read data, could be a lot more, because maybe even though we started streaming the data from the data source very quickly, it took quite a long time to get all of the rows of data out. Alternatively, as in this case, we can see that it took a long time, relatively long time, 1.3 seconds, to get the data and the first row, but then after that, boom, all the data came very, very quickly in 6 milliseconds, so very, very quickly. So these are the two numbers you need to look at when you're tuning your Power Query queries. It doesn't really matter whether one or the other is large. Look at them both together and look at them kind of added together, really. OK, so we know how long it takes to run a Power Query query as a result of this. Of course, in the real world, with a data set connected to analysis services, multiple queries could be run in parallel, and there may be greater or lesser amount of parallelism. My colleague on the CAT team, Phil Seamark, has written a really good blog post about visualizing what happens inside the analysis services engine when a dataset refresh takes place. And actually, I think I have got his blog post up open in the browser. Here we go. I highly recommend using this. It talks you through connecting Profiler to either Power BI desktop or the Power BI service through the XML endpoint. And it will show you how long stuff took, and it will show the amount of parallelism that took place. Because when you run a query, refresh a data set, not all of those tables will be refreshed in parallel. There are limits on the amount of parallelism, and the order that these things get executed will also have an influence. But it will tell you that useful information about how long the Power Query queries took. So that's really great. If you know something about Power Query, you'll be thinking, but Chris, Doesn't Power Query Query Diagnostics give you some of this information? Yeah, it does. It gives you tons and tons of really, really low-level information. But if I'm honest, none of it is actually really practically useful. I don't use it very much in the real world because it is incredibly difficult to interpret. And if you were trying to look in Power Query Query Diagnostics at how long your queries took to refresh overall, well, it's just going to be way too confusing. So I wouldn't even bother looking at Power Query Query Diagnostics for this. That is a data set, and Power Query feeding data into a data set. The good news is, in the world of Dataflows, you've actually got a lot more detailed information in a much more consumable way. When you've got a data flow, you can actually download a refresh history CSV file, which gives you all the obvious data that you would want for a data flow refresh. Now, I have got a data flow open here. For reasons that I won't go into, but because I'm doing all my demos in the Microsoft Power BI environment, I can't show you the relevant screen in the Microsoft Power BI environment because there is a feature enabled there that you're not allowed to see. But if we go to my personal tenant and we look at a different data flow, these are not the data flows that I'm playing with here. But if I was to go through to here and select a data flow, you can see that there is a refresh history option up here, and you can download the CSV file here. So that's where you would see it. But if we go back to here, here is exactly the same set of Monday and Tuesday queries done as a data flow. I have already downloaded the CSV file, and because CSV files aren't really very easy to read, I've loaded the contents of that CSV file into Excel. And we can see here that when the data flow refreshed, there were two tables, Mondays and Tuesdays. We can see the start time, the end time, and most importantly, we can see the duration for both of them, which makes a big difference. There is a ton of other useful, interesting stuff that might come up in different circumstances, but it's those durations that are the key thing. So for a data flow, it's actually much, much easier to see how long something took to execute. All right. Moving on. We're now ready to think about maybe doing some performance tuning. I think we're probably already like more than halfway in. What can we do? OK. The first thing to understand to be able to try and make my Power Query queries run faster is to understand where the queries execute. Where does Power Query do all of its work? It's mostly obvious. If you're in Power BI Desktop, the Power Query engine runs inside Power BI Desktop. If you're running in the Power BI service, though, either in Dataflows or your data set is actually refreshing, doing a kind of scheduled refresh for a published data set, it depends. If you're connecting to cloud-based data sources, well, in the Power BI service, in a data set or a data flow, you can connect directly to the cloud-based data source. That means the Power Query engine executes inside the Power BI service in the cloud. In Premium, you might have more resources. Therefore, your queries are likely to run faster if your data flows or data sets run in a premium capacity. If you're connecting to an on-prem source, or if you have a Power Query query, a single Power Query query that combines data from on-prem and cloud sources, then that query will have to be executed on an on-prem gateway. So if you're connecting to an on-prem source and you're doing transformations, the Power Query engine executes on the on-prem gateway server, which means that's where you need all the resources. And the mistake people make is that they don't read the documentation, which quite clearly says you need to have quite a lot of resources on your gateway server, and they will put it on a 4 gig super cheap virtual machine, and then they will wonder why things are super slow. It is also worth pointing out that when you scale up your gateway PC, your gateway server, even if you don't think all of the resources are being used, scaling up can improve performance, because as you scale up the resources on your gateway server, the amount of resources available for a single Power Query query to refresh are also scaled up. So it's all done as a kind of relative calculation. The amount of resources available for one Power Query query is calculated relative to the total amount of resources on the machine. So scaling up can make things faster, even if you don't see your gateway server under stress. And of course, you can scale out as well by clustering, which means that there's going to be less contention if lots and lots of data sets and data flows are executing at the same time. Next, I said I wouldn't talk too much about this, but it is relevant. The type of data source you use will have an impact on Power Query query performance. Generally speaking, the data sources you want to use for the best performance are relational databases of some kind. I'm not going to force you to use a Microsoft one, but generally speaking, relational databases are going to be the best place for Power Query to get its data. We will find out more later. Certainly, even if you're just getting data and not doing any transformations, SQL queries and things will be executed, and you'll want a friendly DBA to go away and tune those queries. If you're thinking about getting data from somewhere else, say from a text file, bear in mind that there are different kind of classes of text file. Generally speaking, CSV files are good. Power Query can stream data and read data very efficiently from CSV files. JSON files and XML files, and especially Excel files, can be really, really slow. Excel is possibly the slowest possible source that you can use for the Power Query engine. Putting your data in SharePoint can be pretty slow as well. We do occasionally see problems where complex stuff happens in a Power Query query. Power Query needs to get lots of data very, very quickly from SharePoint, and then SharePoint thinks, oh, this is like a denial of service attack, so I'm going to throttle you or cancel you. Web services can be slow, and if you're moving large amounts of data over the internet or over a network latency can play a part. So fast data sources are going to be important, and remember, it's not magic. Do whatever tuning on the network or on the queries that are generated. Now let's talk about query folding. So earlier we saw how, with that kind of demo with the wait-a-sec function, when the Power Query query is executed, it doesn't go step by step. It looks at everything you're doing and kind of compiles it all into a single operation to try and do things in the most efficient way possible. For certain data sources, that can result in queries being generated back to the data source, which includes some or all of the logic used inside your queries. So rather than just grabbing all of the data and then applying a filter, it will just say, well, OK, Chris wants the dim date table, but he just wants the Mondays. So why don't we just generate a SQL query that says, select star from dim date where English day name of week equals Mondays, which makes sense, right? This is what query folding is all about. It's about understanding what's happening inside your Power Query query, and rather than Power Query doing the logic itself, pushing that back to the data source. This is only possible with some data sources, because not all data sources have got query languages that we can generate to push query back to. Obviously, relational databases have SQL. Analysis Services has DAX and MDX. Azure Data Explorer has KQL. OData web sources have a kind of query language in the filter, and so on. Different data sources will also support different query folding, because some data sources like OData have got kind of limited transformations they can do. Some connectors just don't know how to turn complex transformations in Power Query back to the relevant query language. So different things will fold in different connectors. And there's other stuff. There are some transformations that will stop folding happening. There are certain things like data privacy settings. I've got a whole presentation on data privacy settings that I encourage you to check out. That can affect how query folding takes place, and so on. But how do we know when query folding takes place? Let's go back to the Power Query editor and click Transform Data. And let's look at our Mondays query, which, remember, just filters dim date by Mondays. We can be sure that query folding is taking place if we right-click on a step in the query and we go to the View Native Query option back here, and we see the SQL query that gets generated for this. So when this query executes, I can see that it is generating a query that says, select all those columns from dim date, where English day name of week is Monday. This is exactly what I want to happen when this executes, so that's good. And this is why Power Query works the way it does, because it allows it to do this. A very common misconception, one that I see repeated in presentations and blog posts, is that if View Native Query is not available, that means query folding is not taking place. This is not correct. Just because View Native Query is grayed out, query folding could still be taking place. There are some sources where the View Native Query option is not enabled, but query folding does take place. For example, OData. And quite often, some of the steps in your query may be folded, but not all of them. So the only real way to know what's going on is to actually have a peek at what the Power Query engine is doing in the background. Now, this is where query diagnostics can be useful, because for a lot of sources, you can look in query diagnostics and you can see the SQL queries or the web service requests that are being generated. So that's good. Otherwise, you might need to use Fiddler. You might need to use Profiler, or the equivalent of your relational database, to see the queries that are being generated. So that's query folding. Query folding is generally a very good thing because, of course, why would you do transformations in the Power Query engine when the data source you're using is probably going to be a lot faster? It's not always a good thing. I have seen rare occasions where actually it would be much more efficient to grab the data and do the transformations in the Power Query editor. The good news is Dataflows, again, are a little bit more mature. If we go to Dataflows, and we have a look here, we not only have the View Data Source Query option here, but we also have these things called folding indicators, step folding indicators. And if we go and we let this refresh, come on. Hopefully this is still working. What we'll be able to see in a lot of cases is some little icons here that tell us whether folding is taking place. Now, I know, for example, a step that will not fold on SQL Server is if I add a column and add an index column. A column that just adds a running incremental number like this. And here, you can see that there is a little red icon here. This indicates that this will not be folded. The filter on English day name of weeks will still be folded. It's just it will run that SQL query, and then the transformation to add the index column is going to be done inside the Power Query editor engine. So not necessarily a bad thing, because just adding that index column might be fairly trivial. Another nice thing that we've got here in Dataflows is if we go to View Query Plan, there's good documentation telling you how to interpret all of this. We've got a diagram that shows us, for example, here is everything up to that index column step. We can see that that was all folded because it's got this remote marker on it, and it's running a native query. And then here, we've got the index column. The good thing is here, it's still not so bad because the output from that SQL query is being streamed. It's not being buffered anywhere, and we're just kind of adding the incremental number column as the data comes in from the SQL query. So streaming is not so bad. This leads nicely onto the topic of data flows and the enhanced compute engine. So if you are using Power BI Premium, and you're using Dataflows, you have the option to use something called the Enhanced Compute Engine. And as I said right at the beginning, the Enhanced Compute Engine kicks in after you've loaded data into a data flow. You then have the option to say, well, for the next set of Power Query queries that I use, if that's using data that's already staged inside my data flow, I can say, well, let's, in the background, load that data into a database that runs. We don't see what it is. I believe it's an Azure SQL database. And then all the transformations we do a bit further downstream will be done on the data held in that database, which means, of course, they could fold, which is great. So if we go back up to our queries here, what's going on? Well, this is exactly what I had in Power BI Desktop. I've got Mondays and Tuesdays, and you can see that dim date is in italics, which means that it's not being loaded into the data flow. At the moment, this works in exactly the same way as this pair of queries we had in Desktop, which means that dim date is just like a kind of bit of shared logic, and the enhanced compute engine in this case is not being used because both of those queries run, the output goes to ADLS Gen 2, there's nothing for it to do. Now, if instead I go to dim date here and enable load, I am now loading the output of dim date into ADLS Gen 2 storage, which then means the enhanced compute engine can kick in. The contents of dim date will be loaded into a database, and the Mondays and Tuesdays queries will both get the data from that cached data in the database inside the enhanced compute engine. You can see now that that's happening because they have that little Harry Potter lightning symbol on them, which tells me that they're computed tables. Is this going to be faster? Actually, no. In this case, I'm pretty sure it's going to be slower because, of course, it's going to be much faster just to do what I was doing anyway, to run 2 SQL queries rather than grab the entire dim date table, stage it in the database, and then run the same queries on that staged copy of the database. So the enhanced compute engine is not necessarily going to be faster, but it could be if you were running you're grabbing a large amount of data from a non-foldable source like a text file, or you were doing complex transformations. So it's definitely an it depends type moment. Right, the last big topic that I want to talk about is memory usage. Now, if everything folds or everything just streams through the Power Query engine, Power Query is going to be fine because it doesn't need to do that much work itself. However, there are going to be some situations where the amount of memory available to the Power Query engine is crucial. Now, every time a Power Query query runs, it runs in something called a mashup container. These mashup containers are separate processes. You can even see the little blighters if you look in Task Manager, and you'll see them here underneath the main Power BI desktop thing. These Microsoft mashup evaluation containers. And when they run, there is a maximum amount of memory that they can use. How much is that memory? Well, it depends. It depends on whether you're in desktop, in the service, in premium, on a on-prem gateway, how much RAM is available on on-prem gateway. Basically, you can't really tell unless you're working in Power BI desktop, but the more the better. And in certain circumstances, the amount of memory available for doing your transformations in a container is going to be absolutely crucial because there is a fixed amount of memory, physical memory that they can use. After that, they will start paging stuff to disk, and as soon as paging starts happening, performance just goes off a cliff. So the key thing is to try and avoid using as much memory as possible, and also to, if you do need to do stuff in memory, reduce the amount of memory you use. Now, there are going to be some cases where you want to buffer data in memory, and some cases where you absolutely do not want to buffer data in memory. There are lots of situations where you might look at your data source and you can see the Power Query engine making multiple requests for the same data, which is very, very slow. In those situations, you might think, well, I want to buffer that data in memory, so I get the data once, and then I can do stuff useful, do good stuff with it in memory. That can be really good for performance. If, however, you go away to get to the data source, you buffer a really large table in memory, and that's more memory than the Power Query engine is allowed to use, and then paging starts happening, that can be super bad for performance. So it depends. Query diagnostics does, again, try and show you the amount of memory used, but generally speaking, it can be a little bit confusing because the containers, in at least Power BI desktop, will hang on to memory and not release it after you've run an execution. So it's complicated. Now, the key thing to understand about memory usage is that if you are not folding, there are some transformations which require data to be buffered in memory. Things like sorting a table. If you're getting data from a CSV file and you're sorting it, well, that's going to be buffered in memory in order to be able to sort it. If you're getting data from CSV files and you're doing merges, which is Power Query terminology for joins, then that will need to happen all in memory. So that's why if you're getting data from non-foldable sources and you're kind of merging two big tables, that's why performance is really quite often really bad. You can manually force buffering to happen as well using the table.buffer or list.buffer functions. But generally speaking, the best thing to do in this situation is to avoid loading as much memory data into memory as possible by reducing the number of columns, filtering the rows before any buffering happens. But it can be super difficult to understand when buffering isn't happening. Dataflows, again, can tell you. If you remember the query plan stuff I showed you, it will actually give you a full scan type of indicator if buffering's happening. But that's not always completely reliable anyway. The best thing to do is to, if you need to do joins and sorts, use a foldable source. And if you don't have a foldable source, try and use the enhanced compute engine in a data flow. That's the important stuff I wanted to get across. There are, of course, all kinds of really obscure scenarios where particular sources and particular transformations can be tuned. There are a number of connector-specific settings that you can change, which will improve performance. I've got links here to various blog posts, but I don't want to bore you by going into them. You'll get the slides afterwards. There are various blog posts I've done about how you can tune individual types of queries. Like, for example, removing duplicates on a column gives Power Query a hint that all of the values in a column are unique, and therefore, it can do certain things like aggregations after a merge much more efficiently. But these are very, very specific things, and things that you wouldn't really even begin to understand until you've learned all the stuff that I told you. The very last thing that I want to tell you, and this is really important, is that there is extra stuff the Power Query engine does in desktop which doesn't happen in the service, and which can really slow down your development time. And these are kind of really super simple things that can make your life very, very easy. The first thing is that when the analysis services engine does a refresh, it will say to Power Query, oh, these tables you're giving me, what are the columns in them? How does the Power Query engine know what the columns are? Well, in most cases, what it does is it goes away and has to run a query against the data source to work out what columns are in the table. Now, it will basically take your Power Query queries, and it will say, but actually, I don't want the full data. I might want the top 0 rows, or the top 1, or the top 4,096 rows, so I can understand the schema of the result set. This only happens in Power BI Desktop, but it can be an immense cause of pain. There's no really easy way of stopping it, but although I do have a blog post about it. You just need to understand it only happens in desktop, and it's not something that will happen in the service when you're doing a refresh. This can be really bad if you're using a non-foldable source like Excel. It can be really bad if you're trying to do a query on top of a view. The other thing is, well, the second important tip is that Power BI Desktop, when you do a refresh, not only refreshes your data, it refreshes all of the little previews you see in the Power Query editor for all of the individual steps. So, for example, here, I can flip between source and filtered rows, and I see a little preview of what the data looks like. Those get refreshed when you do a refresh in Power BI Desktop. If you have lots of queries with lots of steps in, refreshing all those previews can actually take way longer than doing all of the refreshes themselves. You can stop this happening by going to File, Options and Settings, Options. And hopefully this will come up. And changing these background data settings. So here under Global, there are some options that allow you to say whether that does or doesn't happen. You can say, let's only do this for certain files, in which case there will be another set of options you can do on current file here. So turning off that data previews in the background option can make your development life so much nicer. And then the very last thing to say is, after all of the memory stuff that I was talking about, in Power BI Desktop, you are actually allowed to give each container more memory. And you can do that here by increasing the maximum memory used per simultaneous evaluation. The default now is 432 meg. It used to be 256, so they've bumped it up. But if you know you're going to be doing some really memory expensive transformations when you're developing, just bump this up to a gig, and it can make everything run so much faster. That's it, though. That's all I wanted to say. There are lots and lots of links in the slides when you get hold of them. Please leave your feedback, and I can take questions. Sure. Shall I do the questions myself? All right. Matthew, you had your hand up first.
Yeah, you talked about query folding and ways to change that. There's a function called value.metadata. Is that reliable, or is it?
So the question is, with query folding, there is a function called value.metadata. Is that reliable? Yes, value.metadata allows you to see data, metadata related with any value. I wouldn't say it's going to be reliable, no, not necessarily. Some of the metadata that gets associated with the table is the native query, but that's not always going to be the case. It's not always reliable. Next question.
In your Dataflow example, you brought the dim date table into the same, I guess, Power Query container.
Mm-hmm.
If you had loaded that to another Dataflow, would enhanced compute still be available?
So the question is, if I was in my example with like dim date and so on, could I get the enhanced compute engine working if they were in separate data flows? Then yes, the answer is yes. You can get the enhanced compute engine working, I think. Next question.
Chris, there's a setting in Desktop where you can either turn off, I think it's parallel loading, on
Yep.
your queries. What happens if you don't have that turned on, turned off? Where does that loading happen in terms of, and what's the sort of major impact turning it on and off?
Okay, so the question is, there is an option in Power BI Desktop that says, do I load queries in parallel? And as it's by default, your queries will be loaded in parallel. If you turn it off, then they will all be loaded sequentially. Now, the usual impact of that is that if you load things sequentially, things will be a lot slower, but sometimes it can make things faster, because the Power Query engine actually has its own kind of disk-based cache for results that are brought back from some sources. And in some cases, if you are reusing the results of the same query across multiple different queries, you can make one call to a data source, get the data, it'll be stored on the disk-based cache, and then if you're doing things in sequence, i.e. not in parallel, well, the next query that comes along will be able to make use of that cached data. So it can make things faster, but I would say 99% of the time it'll make things slower. Yes.
For the Dataflow refresh history,
Mm-hmm.
if you want to monitor it over a week, for example, is there any easier way than going to each single refresh and downloading the CSV?
So the question is there an easier way to get the Dataflow refresh history rather than downloading? That is a good question. I believe not. Sorry, but we should probably do a better job with that. Going back to the previous question, it is worth pointing out that if you want to know whether the enhanced compute engine is being used, the Dataflow refresh history actually tells you. So rather than relying on me and my faulty memory, do your own tests. The refresh history will tell you whether the enhanced compute engine is being used, and indeed whether any folding is happening against the enhanced compute engine. Any more questions? Yes. Mm-hmm. Okay, so the question is, I've done all my demos in desktop. What happens in the service? Now, it's really important to distinguish between loading data, which is what I've been talking about here, and report refresh, which is completely different. Because if you're using import mode, when your report runs, that all takes place completely separately to refresh. Now, but if we're concentrating on refresh, and you want to know how long refresh takes in the service, you're going to have premium. And if you've got premium, you have the option of having the XMLA endpoint turned on. The XMLA endpoint makes a Power BI dataset appear like an analysis services database, which means that you can connect Profiler up to the XMLA endpoint, and you can do exactly the same tracing that I did here against desktop against your dataset in the Power BI service. Any other questions? I think we're probably done here. Thank you very much.